Today we are going to talk about how to use multiple I2C devices with the same address.
As you can see, I'm in my room in the place where I'm staying. We've been placed under a 14-day quarantine because two residences here have been tested positive for the coronavirus, and we possibly have a third one that went to the hospital. So I'm doing this video from my room. Now, as Jody said, we are basically doing a video on how to do multiple devices, multiple I2C devices that all have the same address. So normally you wouldn't be able to use them in this case, 4 LCDs on one I2C bus. So let's get to the video and explain what I'm talking about and how to fix that problem. Talk to you later.
Hi everyone, Jody, Joy here. Richard. You got me doing it now. In the last video we talked about the I2C and how you can use multiple devices on the one I2C bus, but only if each one has a different address. Multiple I2C devices, same address? But what if you have multiple peripherals with the same address? For example, multiple OLED displays or multiple BME280 sensors? There are several solutions. First, you could change the device's I2C address, or you can use an I2C multiplexer. Changing the I2C address. Many breakout boards have the option to change the I2C address depending on its circuitry. For example, take a look at this OLED display. By placing the resistor on one side or the other, you can select different I2C addresses. This also happens with other components. Using an I2C multiplexer. However, in this previous example, this only allows you to have two I2C displays on the same bus, one with a 0x3C address and another with a 0x3D address. Additionally, sometimes it is not trivial changing the I2C address. So, to have multiple devices with the same address on the same I2C bus, you can use an I2C multiplexer like the TCA9548A that allows you to communicate with up to 8 devices with the same address. ESP32 using two I2C bus interfaces. You can also use the two I2C buses that the ESP32 has. To use the two I2C bus interfaces of the ESP32, you need to create two 2-wire instances. Then, initialize I2C communication on your desired pins with a defined frequency. Then, you can use the wire.h library methods to interact with the I2C bus interfaces. A simpler alternative is using the predefined wire and wire1 objects. Wire.begin creates an I2C communication on the first I2C bus using the default pins and default frequency. For the wire1.begin you should pass your desired SDA and SCL pins as well as the frequency. This method allows you to use two I2C buses, one of them uses the default parameters. To better understand how this works, we'll take a look at a simple example that reads the temperature, humidity, and pressure from two BME280 sensors. Each sensor is connected to a different I2C bus. I2C bus 1 uses PO27, SDA, and PO26, SCL, and the I2C bus 2 uses PO33, SDA, and PO32, SCL. Let's take a look at the relevant parts to use the two I2C bus interfaces. Define the SDA and SCL pins you want to use. #define SDA_127. #define SCL_126. #define SDA_233. #define SCL_232. Create two 2-wire objects, two I2C bus interfaces. 2-wire I2C1 equals 2-wire 0. 2-wire I2C2 equals 2-wire 1. Create two instances of the Adafruit_BME280 library to interact with your sensors, 1 and 2. Adafruit_BME280 1. Adafruit_BME280 2. Initialize an I2C communication on the defined pins and frequency. I2C1. Begin SDA_1, SCL_1, 100,000. I2C2. Begin SDA_2, SCL_2, 100,000. Then, you should initialize the BM1 and BM2 objects with the right address and I2C bus. BM1 uses I2C1. Bool status equals BM1.begin 0 by 76, and I2C1. And BM2 uses I2C2. Bool status 1 equals BM2.begin 0 by 76, and I2C2. Now, you can use the methods from the Adafruit_BME 280 library on your BM1 and BM2 objects to read temperature, humidity and pressure. Programming to use the TCA9548A I2C Multiplexor with 4 LCDs with the same address. If you have not set your Arduino IDE to work with your board and Alexa, please watch parts 9.2 and 9.3. This is an add-on to the last sketch we did. We will post the full code in the description. To follow along, we suggest that you download the sketch. You see the wire library. This is needed to use the I2C bus. This is set up to only be used with an ESP32. This library is needed so that Alexa can work with the devices you are going to use. You will need this library for the liquid crystal display to print and show your caricatures. We have to add this line here. Even though we don't have to add a library for the multiplexer, we do have to tell it that we have it and what the address is for it. Next, you will see that 3 lines are commented out. These lines would be used if, say you were going to place more than one of the same devices on one channel that had different addresses. You would give each device a unique name and tell it the address the device is using. In our case, we are using 4 liquid crystal displays that all have the same address, so we only have given the address that all of the displays have. Each display will be repeated by the channel they are on. This will be explained later in the sketch. This line here, about all I can say is that it declares of our print routine. Don't ask for an explanation, we have no idea what it does, we only know that you need it for this to work. On the other hand, here is where we are setting the multiplexer's channel, and how we call each channel. This line you want to set to the number of channels you are using, or are planning to use. At this time we don't know how many channels we will need by the time we are done, so we set it to use all 8. Note, the channel numbers start at 0 and ends at 7. Down here, like in part 9.3, we are giving each relay a name and the GPIO pin assigned to that relay. Later we will be adding a GPIO multiplexer that could give us up to 48 additional GPIOs. This section is where we gave a name for each device's callback. And this is where we tell Alexa what the name will be when you ask Alexa to turn a device on or off. In the setup you will want to set your serial baud rate. I always set hours to 115,200, because we have a high-end computer that can handle the speed. Now we tell wire to begin. In this section here, we are basically initializing each display. Look here at the start of each line, we first tell the ESP32 what channel on the multiplexer we are addressing. This line tells the LCD where to start printing. And this line is telling it what to print. The next few lines tell it what device we are addressing and initializing. This here is not needed for the sketch, it was just something to print before the next section. Now we set all of the relay pins to output. After that, we basically turned all of the relays off, then display the status of the relay on the display. This section tells Alexa which device name goes with which callback function name. If you watch the other parts, you know what we are going to tell you here. For those of you that haven't, in the loop, the delay must be set to 5 or higher. If not, Alexa will not find all of your devices, if any. This is the last area of this sketch we are going to cover. This is the actual callback functions. This is what turns on or off your relays, and prints it to both your serial port and the LCD depending on what you tell Alexa to turn on or off. Here you see that the line that prints for a relay to be on has a space at the end. That is because if you look at the line that prints that the relay is off, it's 1 character longer than the line that says on. That would mean that if you don't have that space at the end of the line that says it is on, when you turn it on, it would leave the last F in the word off there. Let's see how you would wire it. First, plug everything in. We started out with the ESP32, and then we placed the liquid crystal displays. We add a small piece of balsa underneath to support the LCDs. Here we are connecting the power from the 5 volts to the 2 power bars, and then the ground to the power bars. Next, we connected the ground of each LCD to the ground bar, and then the VCC to the power bar. We then plugged the ESP32 to give it power, and to make sure the LCDs were lighting up. Next, we placed the multiplexer on the board. Connect the data on the LCD1 to the SD0 on the multiplexer. Then the clock to the SC0. We then repeat this for the other LCDs. LCD2 data and clock go to SD1 and SC1. It is time to connect pin 22 on the ESP32 to the SCL on the multiplexer, and pin 21 on the ESP32 to the SDA. LCD3 data and clock go to SD2 and SC2. And LCD4 data and clock go to SD3 and SC3. Now connect the power and ground. It is now time to program the ESP32 with the sketch and see what happens. Watch and see the displays show they are ready. Now they are showing that all of the lights are turned off. Now we do a device search with our Alexa app. Once done, we have 16 devices, and the LCDs show when we turn each one on or off. Thanks for watching this video. If you found it informative, please give it a thumbs up. Please subscribe to the channel so that you can keep up with the Pontoon Houseboat project. Go to our GoFundMe campaign and spread the word. We need your help. As always, stay safe, stay healthy, and stay happy. Here is a list of our most recent contributors in one form or another.